Hello students, welcome to my online lecture session of subject COA. Today's topic is stack organization, which is a part of unit number 3, Central Processing Unit. Objective: in this video lecture, first of all, we will discuss stack organization, which is used to store data. There are two types of stack organization. First is register stack and second is memory stack. Now start our session with first topic, stack organization. First of all, a stack is one type of storage device that store information in such a way that first the item stored last is the first item retrieved. Means it follows the LIFO, last in first out, means last item is removed first. In stack organization, one register is used which is known as stack pointer, which holds the address for the stack and it points at the top item in the stack. There are two operations are performed on stack, which is a insertion of items. It is known as push operation, and second, deletion of items, which is known as pop operation. Now, a stack can be placed in a portion of a large memory, or it can also be organized as a collection of finite number of words, memory words or register. Depends on that. There is two types of stack. First is register stack. Now we will start register stack. In this diagram, this is a register stack which can hold a total 64 words. So first the starting address is 0, then 1, 2, 3, 4 and last address is 63. It can be composed of registers. Now two register is used to indicate, to check whether the stack is empty or full. For that, full and empty 1-bit register is used. DR is a data register. It contains the data, binary data, which is stored in this stack, or the data from the stack can be retrieved and stored in the data register. SP is a stack pointer which points to the last items, last data on the stack. Here 64 word stack is there. That means total 64 word we can store at a time. The stack pointer contains 6 bits because the address total number of word is 64. So that 64 can be written as 2 raised to 6. That means 6 address bits are used for the stack. So stack pointer contains address. So the size of the stack pointer is 6 bits. Stack pointer register SP contains a binary number whose value is equal to the address of the word that is currently on top of the stack. Now here, first of all, at first time, the stack pointer is at the address 0. And suppose this register stack is empty at initial stage. Now first item, which is A, is comes, and to store this item, stack pointer is incremented by 1. Now the value of stack pointer is 1, and at this place the A is stored. After that B comes, so the B is stored at the address 2. Then C comes, so first stack pointer is incremented and it indicates the address 3, and at address 3 the C is stored. Now similar, whenever data comes, all the data are stored according to the stack pointer. When stack pointer points at the address 63, then it switch over to the first address, that means 0, and the data is stored at this 0 location. Now my stack is full, means it starts from the first address and ends at the 0 address. So the items are stored at the addresses first, second, third, fourth up to 63, then after 0. Now for the delete operation, first of all, the data which is pointed by the stack pointer is deleted, and then after stack pointer is removed. And during this stage, these two registers set the value. Suppose the stack is empty initially, then this empty register is set to 1. And whenever this register fills with the data, means overload, then this full register set its value to 1. Now push operation. If the stack is not full, a new item is inserted with a push operation. Now push operation consists of the various micro operations like this. First of all, it increments the stack pointer value, means SP plus 1, and it's stored in SP register. Then after, the value of DR register is stored at the location indicated by the SP. So it is written as M of SP equal to DR. Then check the value of the 1-bit register. If SP equal to 0, that means after the insertion operation, if SP equal to 0, that means my register stack is full. Means up to 1 to 63 is packed with the data items. Now SP equal to 0. Then full is indicated by 1. That means now stack is full and no data items can be inserted in the register stack. So set to empty equal to 0. So in push operation, check the SP value. If SP equal to 0, after the insert operation, then set to full register to 1 and empty register to 0. First item stored in the stack at address 1, means it's a storage push operation is start from the address 1, then address 2, then 3, 4 up to 63, and at last item is stored at address 0. Now next operation is pop operation. For pop operation, first of all, pop operation is performed when there is items, there is a data in the stack. If a new item is deleted from the stack, if the stack is not empty, that means if empty equal to 0, means empty की वैल्यू 0 है, तब हम डेटा आइटम्स को डिलीट कर सकते हैं. It consists of various micro operations like this. First of all, the data which is indicated by the stack pointer, which is a place, which is a location of M of SP, is stored in data register. After storing the data in data register, it decrements the value of stack pointer. Now check the value of stack pointer. If SP equal to 0, that means last SP is at address 0. That means all data items are removed, and then at that time set the empty equal to 1. That means now stack is empty and full equal to 0. That means we can insert new data items in the stack. We can insert new data items. Now these three steps describe the micro operation sequence. Now next topic is memory stack. In memory stack, The computer's memory is partitioned into three segments, three parts: program, data, and stack. Now this diagram shows that my memory is divided into three parts: programs, which is a set of instructions. Main set of instructions is stored in this part. Now second part is data, operands, which is a value which is used by the programs. And the third part is a stack, which is used to store the temporary data. Now for that, for handling of this memory, we use a three register: PC means program counter, address register, and stack pointer. PC is points at the address of the next instruction in the program. That means it stores the address of the next instruction to be executed. AR, address register, points at array of data which is used to read an operand. Now third is a stack pointer, SP. SP point at the top of the stack, which is used to push or pop items into or from the stack. Now in this diagram, the memory addresses are written as 1000, 3000, 3997, then 8, 9, 4000, 4001. Means addresses increment from top to bottom. So first of all, we check the stack operation. Now stack is store the items in LIFO manner. So suppose my item is stored at initially the stack pointer is at the value 4001. For example, now I just want to store one data items. Then after I have to first go to the next address, means 4000, which is a decremented value of the address. So in this memory stack, we have to first decrement this value of stack pointer. Now we are here at the address 4000. Now at this place we can store the data. After storing the data, suppose I have another value. For that again I have to decrement the stack value because I have to reach at the 3999 address, which is a decrement the value of stack pointer. Now this location my data is stored. Again, whenever I just want to insert an item, then first of all I have to just decrement the stack pointer, and after that at that location data is stored. In reverse, suppose I just want to delete an item, then suppose my stack pointer is at address 3999 and I want to perform pop operation. Then first of all this data item is placed to the DR register, data register. Then after I have to just increment the stack pointer because here my address becomes 4000, which is a increment by 1. Means the stack pointer is incremented by 1. Then after I get the 4000. Now three register PC, AR and SP, which three registers are connected with the common address bus to communicate with each other. Now push operation. Push operation contains two microoperations. First of all decrement the stack pointer by 1. Then after place the value at that location. That means the content in data register are placed in M of SP, M for memory. Here stack pointer is first decremented so that it points at the address of the next word. And memory write operation inserts the word from DR means data register into the top of the stack, which is pointed by SP. Now pop operation for memory stack. In this case, first of all the data at location pointed by at address pointed by SP. That means M of SP is placed in data register. After placing the binary data into data register, the stack pointer is incremented by 1. So pop operation, in pop operation, first of all we have to read the data from the stack into data register, and then after the stack pointer is incremented to point at the next item in the stack. Now in most computers there is no hardware for checking the stack underflow or stack overflow. Means here there is no any extra register in a register stack empty and full. In this memory stack there is no registers is used. But we can implement it by checking the two processor register. Uh, First is upper limit, which is stored the upper limit of the register, and then second is the lower limit of the memory stack. After push operation, SP is compared with the upper limit of register. If if the SP achieve the upper limit, then there is no possibility of to insert the new data item using the push operation. And after pop operation, delete operation, SP check with the lower limit. If the lower limit is exceed, then there is no possibility for the pop operation. Thank you.